Plant nutrients are essential for growing the crops we need to feed a rapidly expanding global population. The development of modern fertilizers has benefited billions, helping to feed over half the world's population and replenishing our soils, while creating wealth that supports communities and development. But nutrient losses to the environment can occur if nutrients are not used properly. Growers use the 4R nutrient stewardship system to sustainably maximize the economic, social, and environmental performance of nutrient application. They start by setting their economic sustainability goals to increase yields and profits that in turn support rural development. Alongside this, they identify their environmental and social goals, such as improving soil quality, reducing nutrient losses to air and water, and growing more food for communities. They meet these goals by implementing site-specific best management practices, BMPs, which enable growers to make the right decisions about nutrient source, rate, time, and place. All 4Rs need to be addressed together to ensure nutrients react with the soil and plants in a way that achieves optimum crop uptake and reduces nutrient losses. Let's take nitrogen, the nutrient most commonly used in food production. This vital nutrient is required to produce healthy food and replenish soils. However, its application needs to be properly managed to prevent the production of greenhouse gases. In moist and well-aerated soils, plants primarily absorb nitrogen from soils as nitrate, NO3, and also as ammonium, NH4. But in waterlogged soil, there is very little oxygen available for bacteria that live in soil. Under these conditions, some of these bacteria adapt by using nitrate rather than oxygen to respire. As this occurs, they release a variety of gases, a process called denitrification. Most of the gas released through denitrification is in the form of N2, which is naturally occurring and makes up almost 80% of the air we breathe. But a small amount is in the form of nitrous oxide, N2O, a greenhouse gas, 300 times more powerful than the most common greenhouse gas, carbon dioxide, CO2. Denitrification is a natural process that we can't completely prevent. However, by using 4R techniques, we can greatly reduce the amount of nitrous oxide produced while still meeting sustainability goals. We start with right source. If soils are susceptible to becoming waterlogged, we select fertilizers that don't contain nitrate, but instead supply nitrogen as ammonium, NH4, or urea, NH2,2CO. Bacteria will eventually change these to nitrate, but this takes time, reducing the amount of nitrate present in waterlogged conditions. We then work to ensure the right rate of fertilizer is applied for the soil and crop, providing sufficient nitrate to optimize yield, but avoiding the buildup of an excess. BMP techniques like soil testing, plant tissue analysis, precision agriculture, and computer modeling help avoid a surplus. It's challenging to predict the weather, but farmers strive to apply nitrogen fertilizer so nitrate will not be present when the soil is waterlogged. We call this right time. In cool, dry regions, growers might apply nitrogen later in the fall, when bacteria are less active, reducing the amount of nitrate present in the spring. In warmer, moister regions, application needs to take place just before seeding or during the growing season. Farmers adhering to 4R also avoid spreading nitrogen sources on the soil's surface, where it can be converted to ammonia and lost to the atmosphere. Using the BMP of concentrating fertilizer application in a narrow band under the soil surface keeps the bacteria from quickly converting the nitrogen to nitrate. This is right place in practice. By combining all of the 4Rs, growers can use science in a practical way to better manage nitrate in waterlogged soil. And while each of the 4Rs alone will reduce greenhouse gas emissions, reductions are much greater when all 4 are used together. In some regions, farmers calculate the reduction in greenhouse gas emissions as a result of applying 4R BMPs. They can sell these as offsets to companies working to reduce their emissions, sustainably improving the farmer's income. Sustainably managing fields and food production is a huge responsibility that farmers accept on our behalf. Using the 4R nutrient stewardship system, growers can increase productivity, helping feed and bring economic and social benefits to communities, while also protecting the environment for future generations.